Okay. Guess my parallelogram and centers of a triangle. Essential question. When are altitudes and medians the same line? And where do altitudes, medians, and angle bisectors intersect? For those who are new-ish to my class, at the end of your notes, you should be answering those essential questions in a paragraph. Yeah. Yep, that's why we write essential question every day. After you finish the notes, you should be able to answer those. Because it's your writing, it's not copying my writing. It's using your brain to summarize. Because if you can put math into your own words, it actually means you know it better. If you can explain math in your own words. That's why you do the summaries. Okay. I'm going to pass out a ruler to everyone. And I would like you to draw, please. Oops, I guess we don't need those yet. Take that off. A parallelogram. Take a ruler, pass it back, please. Okay, Andy, you need to move. Andy, would you please go sit in the front seat on the second row over there in front of Isaiah? Yeah. Please move. That will be your new permanent seat. I think I gave you an extra one since Andy's moving. Give me one of those back. Thank you. Thank you, Andy. Yep. Please draw a parallelogram. The rules of the rulers, which right now I can see people are not obeying. You do not spin them on your pencil or your pens. There are only a few things rulers are used for. 1, measuring. 2, drawing straight lines. And that's all we use them for in my class. No, not that. Please draw a parallelogram with your ruler. After you've drawn it, would you please pull out your little gray sheet from last time called Parallelogram Spock? It's Parallelogram Spock. Those people who are not here last time, I have a bunch right here in my hand. You can come up and get one. Anyone else not here last time? Don't touch that, please. That needs the Parallelogram Spock. Where's yours? Okay. I'm going to also pass around staplers. I'd like you to staple Parallelogram Spock to your notes so you don't lose it. Staple Parallelogram Spock to your notes so you don't lose it. Yep, these notes will be just fine. Last time we talked about 5 properties of parallelograms. If you were absent last time, you want to ask a neighbor kindly to borrow theirs really quick so you can write down what we wrote on our little Spock hand. There are 5 properties of parallelograms we talked about last time. 1 is the thumb of Spock. 1 property of one part of the parallelogram. Then there are 2 properties of a second part of the parallelogram. And then there are 2 properties of another part of the parallelogram. So you all should have this in front of you or you're copying a neighbor's, and you will have it shortly. If I raise a hand, who can tell me the thumb of parallelogram Spock, one thing we know about parallelograms? Yes? Okay, what bisects each other? Diagonals bisect each other. on your parallelogram, would you please take your ruler now and draw two diagonals. So diagonals would go like this, from corner to corner. No, put that away. Okay, next phone I see in this class, go straight to the office. I tell you time after time to put them away. It's not okay to have them out. Okay, so the thumb said that diagonals bisect each other. The word bisect we've talked about a few different times. But there's a hand who can tell me what it means to bisect. Say it louder, please, Olivia. Cut in half. I like that. It cuts in half right at the midpoint, which means if we label this A, B, C, D, it means this point right here in the middle, E, is the midpoint. So AE is congruent to EC, and we mark congruence with a little tick mark. Okay, Justice, where else do we have congruent segments that we should mark with a couple tick marks? Okay, give me the two letters on the endpoints. Like this one, I called it A, E. So how would we say those segments? BE creates one segment, and then the other segment is DE. Those are congruent. So we'll mark them differently than the first pair, because we don't necessarily know that they're congruent to each other. Okay, so we have double tick marks. Okay, that was the diagonals. Now there were two things about another part of the rectangle. Okay, two things about another part of the rectangle. Janine, what's another part of the rectangle we talked about last time, besides the diagonals? The what? We wrote it in two of the fingers on the hand. Congruent what? Sides. We have two properties of congruent sides, and she just said one of them. Can you say it louder again? Two pairs of congruent sides. So we're going to mark congruent sides, and they're actually opposite sides. Two pairs of opposite congruent sides. So BC is congruent to AD. And when you actually drew your parallelogram, you should have tried your best to make it congruent. You could have used the markings on the ruler to measure it, or eyeball it pretty close. Okay, Madison, where else do we have congruent segments that we need to mark? Okay, AB is congruent to what? DC. Good. Okay, so that's one property of the sides. Opposite sides are congruent. We have two pairs of opposite sides that are congruent. There's a second property of sides. Liliana, what's the second thing about sides? Two pairs of parallel sides, and those are opposite, right? So here's the marking for parallelism. On AB, if I give an arrow, I have to give CD an arrow. That shows that they're parallel. And I can do the same with BC and AD, but I'm going to give them two arrows to distinguish the difference between our two pairs of parallel sides. Okay, so we know diagonals bisect each other, which means they cut each other, slice each other right in half, and create two segments that are congruent on each of the diagonals. Also, we know two things about the sides. We know opposite sides are parallel and opposite sides are congruent, and there's two pairs of each. Okay, what's the third set? The sides, diagonals, and sides. Who has the third piece? Mara? Angles. We know two properties of angles. Okay? Diana, what's one property of angles? Just Diana. Do you have your parallelogram spot? Yep, look at it. We wrote 2 things about angles.
Opposite angles are congruent.
Yes, 2 pairs of opposite angles are congruent. So, for instance, angle A would be congruent to what angle? C. So we'll mark that, please. Angle A and angle C are congruent. Okay. Vanessa, what's the other pair of congruent angles? Oh, we'll get to that one in a minute. But on congruent angles, I've only marked 1 pair. What are my other 2 angles that I haven't marked? I've marked so far A and I've marked C. What are the other 2 that I have not marked that are congruent? Opposite. Opposite angles. Okay, I'll help you out with the first one. B, there you go. B and D. So we do a double arc. Okay. And Vanessa, you actually started reading our last property anyway. Would you say that loudly for the last thing we know about angles? CIA are supplements. CIA. Who can remember what CIA stands for? Consecutive interior angles. Consecutive interior angles is, they're your neighbors. How many do I have? 3, 5. Take one of these bags of crayons and pass them back. We're going to mark consecutive interior angles with a light crayon. So find a light crayon in your baggie. 2, 3, 4. Take your baggie, pass it back. I'm losing bags of crayons, looks like. 4. Oh, we barely made it. Okay, quickly pass those back. Pick a light color. We're going to highlight only 2 pairs because it's starting to get a lot of markings, which becomes a little confusing. Okay, consecutive interior angles are supplementary. Supplementary, what does that mean? Law, what does supplementary mean? 2 angles are supplementary. What? Ooh, the other one. That's complementary, add to 90 degrees. So supplementary, add to, good, 180 degrees. So, an example of supplementary angles would be across the street neighbors. So you can highlight A and B together. Or they can be next door, A and D. So A and D, those are all, we could go all the way around the rectangle and do D and C are supplementary. Also C and B are supplementary, but I just want to stop there before our picture gets too crazy with all these markings. So A and B together add up to 180 degrees. A and D together add up to 180 degrees. Okay, so that's a review on our properties of parallelograms. I'm going to give you a list, I think, 6 different things of a shape that I'm describing. I'm going to tell you what shape it is, but you need to use some reasoning and discover what shape I'm trying to explain the properties of. So, next to you, find a partner, give them a high five so that everyone has a high five partner. Does everyone have a partner? Annabelle, who's your partner? Pick a partner, quick. Bo or Lucas? Which one of you guys don't have a partner? Are you 2 guys are partners? Okay. Do you have a partner? Okay, who doesn't have a partner yet? Liliana? Oh, you're with. Okay, let me see those high fives in the air. And hold the high fives so I can see whose partners with who. Okay, Isaiah? Annabelle or Isaiah, one of you guys move to the other person. You two can be partners. Is there anyone else who's missing? Should be really close to you. Okay. Well, is there an extra person who's still waiting for a partner? Okay, Madison, just come over. We'll have a group of 3. All right. I'm going to list 6 items about this shape, and together as a partnership, you are to discuss and only be discussing about this example, not other things that are unrelated. You need to stay on task with your discussions. Discuss the properties and decide what shape I'm describing. Here we go. The diagonals of this quadrilateral are perpendicular to each other. The diagonals of this quadrilateral are congruent. When rotated 90 degrees, each diagonal of this quadrilateral gets superimposed on top of each other. That means it lines up. If you put it right on top, it lines up. Okay? Consecutive angles of this quadrilateral are supplementary. That is, they add to 180 degrees. And consecutive angles of this quadrilateral are congruent. The diagonals of this quadrilateral are congruent and perpendicular to each other. So, was that a question?
No, but I know what it is.
Okay, well, don't tell us yet. Okay, discuss with your neighbor. Okay, I would like you to turn the opposite direction, find someone from a different partnership, and discuss what you and your original partner talked about. Brady, you can jump back with them or come over to these guys. You have 10 more seconds to figure out what shape I'm describing. 3, 2, finish your conversations, please, in 1. Everyone return back to your assigned seats, please. Also back to your assigned seats, please. Okay, thank you. Assigned seats. All right, so one idea of how you could go about this would be to kind of sketch what it's talking about, step by step. First it says it's a quadrilateral, and diagonals are perpendicular. Jared, what does it mean to be perpendicular?
Where they're
They can just intersect wherever? There's a little bit more to it. Yes, perpendicular intersects, but I need something specific about perpendicular. What about you?
Oh, it has to be like a right angle.
Ah, there we go. A right angle, 90 degrees. So if I start to sketch this, and I have a diagonal and another diagonal, they have to intersect at a right angle. And it says, number 2, the diagonals are congruent. So I drew them as best as I could, as congruent as possible. Okay, now I'm going to combine these two. Let's see if they will group together. We need a right angle in the middle, don't we? Let me group all those again together. Copy, paste, bring this one down. Okay, now number 3 says, when rotated 90 degrees, each diagonal of this quadrilateral gets superimposed on top of each other. So tell me when to stop when I have finished rotating 90 degrees. No, that's 45 degrees. Yeah, I didn't do very well drawing mine, did I? Maybe it'd be easier if I didn't draw it sideways. Okay, let's ungroup this really quick. Oh, yeah, that definitely was not 90 degrees. Let me try actually drawing a 90-degree angle. Whoa, that was not what I wanted to do. Okay. Sorry, let's try this again. I'm going to do the diagonal straight up and down so I actually get a 90. Does that look more like 90? Yeah. Copy, paste. Now let's see what happens. Again, tell me. Oh, that's almost perfect. Oh, it's not giving me the rotating thing. Copy, paste. Huh. This worked much better yesterday. Maybe it's just I need that drawing little square in it, and then I'll get a rectangle. Okay. So if I bring it over here, I just needed that green bubble so I could rotate it. Tell me when to stop when I hit 90-degree rotation. Yeah. So other than I hand drew this, I didn't actually measure to make sure the segments were congruent, but you get the idea. When we rotated 90 degrees, did it end up being superimposed on the original? Yeah. Now, if I connect the sides, I'm just going to take away the top one. If I connect them and actually look at the... Whoa, that is not a marker. If I actually look at the quadrilateral, number 4, consecutive angles of this quadrilateral are supplementary. That is, they add up to 180 degrees. Consecutive, that's CIA. Okay, let's go back to the law. Consecutive interior angles. If I'm looking at this angle right here, what would be a consecutive angle to it? Consecutive, it has to be a neighbor. All the way across? No. It could be either the top one or the bottom one. Okay, and it says those are 180, so I'm actually going to do a different marking for right now until I read number 5. Turn all the way around, please. Consecutive angles of this quadrilateral are not only supplementary, but they are congruent. So these two are congruent, which also means this angle here is congruent to its other supplementary angle. And this angle is congruent to its supplementary. So all 4 angles are congruent. Interesting. The diagonals of this quadrilateral are congruent and perpendicular to each other. So this diagonal from A to C is congruent to diagonal B to D. Okay, so by raise a hand, who can tell me what shape this is? Lucas? A square? Raise your hand if you agree with him. Good. It is a square. Since the angles are congruent, what angle does this have to be? They all have to be 90. So if I draw a 90-degree angle in all of those. So we're getting a square. Here's a question for you. Is this also a rectangle? Is a square a rectangle? Whoa! Shh. Is a square a rectangle? Yes. Explain why, please.
4 sides.
4 sides, and the sides are also, what's that P word? Parallel, and we have 4 90-degree angles. So yes, squares are rectangles. Here's another question. Are all rectangles squares? No, it doesn't go back. All squares are rectangles, but not all rectangles are squares. Yeah, I would say specifically, though, that this was a square. Okay, what we're going to do next is start working on your homework together, because the beginning part is a bunch of constructions, and lots of you don't have compasses, compi at home. So I need a couple volunteers, 3 volunteers to pass these out. Guys, the copier, is just dying a miserable death, and it's always broken whenever I make copies. So I have to do them one side at a time so they're not stapled. So I'll have to pass staplers out. Okay, Andy, Michael, Jaron. You'll need to make sure you get 3 pages. Jaron, not Jaron. I meant Zach. I'm sorry. Sorry. You'll need to make sure you get all 3 pages, and we'll pass out staplers. And make sure they get in order before we staple them. Do one of you have your own? Okay. It's 1%, yes and yes. Okay, I tried to do surgery on all of these and fix most of them. Yesterday there was a class that used them. Hopefully they didn't mess them up. But the compasses should all be working. This is a huge class. I might run out. Oh, that one's really loose. I don't like that one. Oh, I need 2 more that work. One's okay. These ones are okay. To get these 2 that are a little loose, you might just want to share with a neighbor. I don't really have any more. Let's make sure you have all the papers you need. The first one actually has your name on it. It starts with page 39. Did you guys all staple already? There you go. 39 and 40. The next page starts with 41, I believe. 41 and then it jumps to 45. And then it goes 46, 47. So first it's 39 through 41, and on the back of 41 starts 45 through 47. Make sure they're in order. Which one are you missing? There you go. Which one do you need? 46. You have 3. You only need 3. Okay, we are doing your homework right now, so the quicker we get into this, the more homework you get done in class. At this time, I'd recommend clearing your desk except for your compass and the assignment. Since when you use a compass... Alright. Jamie, you also need another seat. Please come over here and sit behind Brayden. Move all your stuff. Your new permanent seat is behind Brayden. What? No. Because you won't know how to do your assignment if you leave. The more problems we get through, the better off you'll be because we're doing your homework right now. But, guys, we've wasted at least 5 minutes already this class period just waiting for you. For the directions for number 1, it says use a compass and a straight edge to bisect the following segments. We've done bisecting a segment before. Okay, so we're going to practice it one more time. Here's a reminder of how it works. I'm going to erase this. Hopefully you figured out your packet. You need to put the sharp point. Let's start on point A. And then you need to make sure you spread out your compass more than halfway. Don't do the full length. Don't go past the full length. Just a little more than halfway. And then we draw an arc. This should be done in pencil, which there should be a pencil on your compass anyway. Next, keeping the same width. Don't shrink it. Try to keep the same width. You carefully pick up your compass, relocate it to B, and we just draw a second arc. You only need to start the arc at the intersection, really, because we were just looking for the intersection points. The reason you have to go more than halfway on your width is your arcs will not intersect unless you go past the midpoint. Who remembers what we do next? Good. Andy, tell us what you just did on your paper. Where does the line go? Yes, good. So right here, top and bottom, where the two lines intersect, line up your ruler, and then connect those points with a line. Okay, this is called bisecting segment. We've talked about the word bisect already today. Bisect means to split into two unequal pieces. No, it splits it into two even. What's another word for even? Congruent. There we go. So if I label this in the middle of the intersection C, I would mark AC as congruent to CB. I'd mark a little tick mark in there. And not only did we do a construct a bisector, it was a special kind of bisector we actually just constructed. Does anyone remember what kind of bisector we just made? What? Yes, thanks, Madison. A perpendicular. So we can even put a little square in there. Now here's a question. Do all bisectors have to be perpendicular? For instance, if I drew a segment right here, it crosses AB at, don't draw that segment by the way, it crosses AB right at the midpoint, which means it's bisecting AB, but is it perpendicular? No. So there's a hint for number 3. Okay, go ahead and construct number 2's perpendicular bisector. Or just a bisector. It doesn't necessarily even have to be perpendicular. When I use a compass and a paper, I think it's easiest to hold the compass steady and move the paper. That works better for me. When you get home, if you have more constructions that we don't get to, if you don't have a compass, even though you could go to the store, they're pretty cheap. They're under $2. Like I saw them at Harmon's the other day for like $1.20, something like that. They're really cheap. But you could always just tie a string on a pencil, and it works just the same way. Or dental floss on a pencil. Okay. The next one we're going to do is number 5. Oops, I didn't want to move that up like that. Let's undo that. Move it this way. There we go. Number 5. Construct the median of triangle ABC. The word median in statistics represents something which I'm sure you've heard before, mean, median, and mode. In statistics, who can tell me what a median represents with a string of data? Okay. Right, Torrance. Get the same hands every time. Torrance. The middle. With data, you line them up in order, though. That's important. And it's the one in the middle. Or when you're driving down the road, and you're going one direction and the opposite traffic's going the other direction, in between the traffic, oftentimes there's a cement barrier, right? Did you know that's called the median? Yeah, it's called the median because it's in the middle of the road. Interesting. Okay, so for us, we're going to construct 3 medians. What that means is we have to find the midpoints. Can't see my letters, but I'm sure that's A and that's C. Okay, so let's start by finding the median or the midpoint of AC. We do that by, similar to what we've done above, constructing a perpendicular bisector, except for we're not actually going to draw that line. So let's do the same steps we did up above. Line it up on A. Okay, and then make sure you make the width more than halfway. We're constructing the midpoint first of AC. Okay, and then draw an arc. Then carefully pick it up. Don't change the width. Carefully pick it up and relocate it down to C. And then draw an intersecting arc. Now instead of drawing a line, you line up your ruler and we want to mark the midpoint. Now to make sure mine actually works out, because I can't put a ruler right on this, I'm going to draw the line, but I'm going to delete that, so don't draw your line. My line's off a little bit. Precision is important or you won't see what occurs from our medians. All I want you to mark is right here. Line up your ruler and mark the midpoint of AC. And now I'm going to delete that line because you guys aren't actually drawing it. What a median is a segment that's dropped from the opposite angle to the opposite midpoint. So now take your ruler and attach B, angle B, to that midpoint. That is a median. Notice it doesn't cross at 90-degree angles. Okay, so we're not constructing a perpendicular here. It could be, potentially, but not in this case. Okay, we're going to do it again. Let's do, how about AB? We need to get another, there are 3 medians. There are 3 sides of the triangle, so we do this 3 times. So I'm going to put my point on B to start with. Make sure your width is more than halfway. Draw an arc. Oh, it doesn't have to be the same width. You can change it for the segment because the segment is probably a little shorter. And then carefully, whoops. So if you did what I just did, we can just remeasure. Okay, carefully. Oh, goodness. Let's see if I can do this carefully without messing it up. Ah, there we go. Carefully relocate down to A. And draw an intersecting arc. Ooh, mine's barely going to touch. If not, dismiss. Line up your ruler and mark the midpoint. I'm going to draw my segment, and then I'm going to delete the segment. So you guys aren't actually drawing this segment right here. Accuracy is very important for what we'll see happens. Mark your midpoint. And then take a look at which angle is across from it. Which angle is across from that midpoint? C. Good. So now line up your ruler from C to that new midpoint. And that creates a median. If yours is starting to get really busy like mine is, we can erase the arcs. Don't erase the segments. Those are important. We can go through and erase the arcs. Because we have one more to do, and it's going to get kind of crazy if we leave all those there. One more to do on side BC. Same idea. Set it up, make sure you spread, whoops, undo that. Make sure your compass is more than halfway. After we do this third one, I want you, when you're finished, to look for a relationship or something interesting that happened when we constructed all three medians. And if you are as accurate as possible, you should see this pop out. Okay, and then again, I will be erasing this segment, so I'm not going to. All we need is the midpoint. And then I'm going to delete that segment. And angle A is opposites, so we connect them. Okay, take a look. If I erase all of these arcs so that I don't have extra stuff making it confusing, take a look at a relationship that happens. Okay, thank you. Turn to your neighbor and tell them a relationship you see or something interesting that happened. Okay, finish your conversations in 3, 2, 1. Okay, Diana. This is Diana. What did you discover? Oh, did you not talk with a partner? You don't see something interesting that happened with our three medians? I wouldn't say they're necessarily equal. We don't know that. They probably would be if it was an equilateral triangle. Isaiah, what do you notice? They all intersect, all three medians intersect at the same point. This point is called a centroid. That will happen with all triangles. Okay, let's try another construction. Okay, on number 6, it asks us to construct not the medians this time, perpendicular bisectors of ABC. So we want a bisector, which means it cuts it right in the middle at the midpoint in 2 equal pieces, and it intersects perpendicularly, 90-degree angle. So we did perpendicular bisectors on numbers 1 and 2 already. Okay, so let's start with segment AB. Oops, don't need that. Need my arrow. There we go. Line it up. I'm going to start on B. You can start on A. It doesn't really matter. Make sure you're more than halfway. Whoa. I think this board is super sensitive because I didn't even touch the board and it did something. Okay. More than halfway, draw an arc. Carefully relocate it over to the other side, the other end point. Draw an intersecting arc. And there we go. Now, guess what? Perpendicular bisectors, you actually do draw the line all the way through the triangle. Okay, line up your ruler at these 2 intersection points and draw your perpendicular bisector all the way through the triangle. All the way through. Okay, accuracy is important, so please try to line it up as close as possible. Okay, line it up with your ruler. Go all the way through. Come on, we're doing your homework. Please do it. Page 1, wherever that is. Now let's do it again. Pick another side. I'm going to do the long side, BC. Make sure you're more than halfway. Perpendicular bisector. So we could actually even mark right here. That's a 90-degree angle. Carefully pick up your compass. Try not to change the width. Relocate it. Whoa, okay, well, didn't quite. I guess mine was at the midpoint and not a little more. Okay, I'm going to try that again so I actually get two intersecting. And I need my square there. So a little bit bigger. Oh, barely. Again, make sure your segment, your perpendicular bisector, goes all the way through the triangle. And then once we do all three, and you can erase the arcs once it starts getting too busy. Once we do all three, you should see a relationship. So one more side to do. Make sure you're more than halfway. I hope you guys see the pattern. We basically just do arcs all over the place, right? Okay, I'm going to erase my red and green arcs because it's starting to get a little too busy. Okay, now if I take these two last arcs and connect them, oops, it's missing the point. I'm going to have to adjust that. What do you notice happens with three perpendicular bisectors? I don't know why it doesn't want to go to that point. That's weird. It's like jumping and skipping it. So mine's skipping it. It's supposed to go right there. But essentially, where do they all cross? They all cross at the same point again, right? Okay, so I believe that's about all the time we have, especially since we're on short schedule. But all these constructions we just did were your homework. So I hope you were doing it with us. Now, I believe there is, if you flip over, please stop moving around. I'll borrow yours for a sec. Okay, I'll wait for you. On the front, number 8, the back of the first page, number 8 is another construction, angle bisectors. We've already done angle bisectors, so it's been a little while. If you don't remember angle bisectors, just Google it. It's all over YouTube. Easy to find. Construction of an angle bisector. And again, if you don't have a compass, tie a string to a pencil and it works just fine. This packet is your homework due next class.